We present Café Talk, the first 3D talking face generation method with coarse and fine-grained multimodal control. Existing methods have achieved impressive progress in facial expression control by using emotion labels or multimodal emotional references for entire sequences, but modeling and flexibly controlling fine-grained facial expressions during speech is still unexplored. It is a novel task for 3D talking face method to enable effective, precise, and flexible controllability. To achieve this, the controlling condition is spatiotemporally modeled as coarse and fine-grained conditions, where the coarse-grained condition establishes a foundation for the produced facial movements and the fine-grained condition enriches the details. Here we demonstrate the significance of Café Talk for animators and AI agent applications. In our case, we direct the avatar to introduce Café Talk angrily by using the words angry and a senior man as our coarse-grained conditional inputs.
Let's have a Café Talk. It is not literally cafe, but is actually a combination of the concepts of coarse and fine into one word.
Meanwhile, we want the avatar smiles when he is saying the word café, so the expression as well as its occurrence interval is provided as the fine-grained condition.
Let's have a Café Talk. It is not literally cafe, but is actually a combination of the concepts of coarse and fine into one word.
Now let's take a look of our technical design. In order to achieve detailed and flexible control within the current diffusion-based framework, an intuitive approach is to directly implement additional fine-grained conditions and jointly train the network alongside speech audio and coarse-grained conditions. However, the entanglement of the three conditions results in unsynchronized lip movements and an inability to fine-grained control. The entanglement of the audio and fine-grained condition provides a shortcut to producing lip movements and weakening speech audio guidance, as the fine-grained conditions can also describe local muscle motions around the mouth. To this end, Café Talk is designed as a coarse-to-fine structure with a two-stage pipeline. In the first stage, a diffusion-based transformer generates the facial movements with encoded speech audio and incorporates the multimodal coarse-grained condition. In the second stage, the fine-grained conditions represent a sequence of action units, which flexibly guide the corresponding muscles to stay excited. With the frozen base model, we design a fine-grained control adapter to gradually add the fine-grained condition into the pipeline without jeopardizing lip movements benefiting from a zero convolution layer. From a data flow perspective, Stage 2 builds upon Stage 1 by incorporating fine-grained conditions as input, which are constructed from a sequence of activated AUs. However, because the model in Stage 2 is only trained on paired coarse and fine-grained conditions, it treats the fine-grained condition as a refinement of the coarse-grained one, which limits its ability to control animation effectively during inference. This issue is particularly noticeable when conflicting fine-grained conditions are provided. For example, if a sudden, exaggerated smile is introduced during an angry sequence, the desired effect cannot be achieved. To address the challenges outlined above, we propose a swap label training mechanism to decouple the provided coarse and fine-grained condition pairs, ensuring that fine-grained control takes precedence over coarse-grained conditions. Specifically, in Stage 2, the emotion label is randomly swapped to a conflicting one, prompting the model to generate predictions based on the swapped emotion label as it was trained to do in Stage 1. Simultaneously, a control mask derived from the AU sequence guides the model, ensuring that the predicted animation remains as close as possible to the ground truth within fine-grained controlled intervals. Through training, the swap label mechanism progressively enhances the model fine-grained control capabilities. The influence of the fine-grained condition could spill over to the neighbor non-conditional temporal intervals due to the continuity of facial movements. This issue cannot be rectified through training alone. Hence, we address it by employing a mask-based CFG technique during inference, which enables precise occurrence and intensity of the fine-grained control. We leverage beta as the intensity control of the fine-grained condition. As shown in the demo video, the eyebrows are raised higher with bigger beta during the controlled interval.
Dogs are sitting by the door!
Which is also reflected on the blend shape coefficients. The choice of using AUs as the fine-grained condition facilitates multimodal control. To extend controlling with textual descriptions of emotions or expressions, we train a text-based AU detector. We collect a dataset comprising text description AU pairs from the knowledge of LLM and image-based expression. The lightweight detector employs clip adapter as its backbone, considering clip's sensitivity to emotions and expressions when aligning textual and visual modalities. We train our detector with a binary cross-entropy loss, while an info-NCE loss is also included to mitigate the gap between AU and natural language descriptions. Now, let's take a look at the generated results of Cafe Talk. Our design for the coarse-grained condition efficiently guides the global generation and achieves multimodal flexible control.
Let's have a cafe talk. It is not literally cafe, but is actually a combination of the concepts of coarse and fine into one word. Let's have a cafe talk. It is not literally cafe, but is actually a combination of the concepts of coarse and fine into one word.
Meanwhile, our method outperforms the existing methods on both lip synchronization and expression generation.
She had a dark suit in greasy wash water all year.
Wow! Amazing! Never expect that would happen.
Next, let's take a look at some examples where both coarse and fine-grained control are used in practical situations, where the detailed facial movements are controlled by natural languages.
Hey, before we say goodbye, I think someone left a little surprise in your bag. Wink, wink. Ha ha ha, he will never know it's us.
Wait, have you told him already?
Doesn't matter. You will find out anyway.
I have been an actor for a decade, and now someone needs to teach me how to laugh. Ha ha, something like this.
Additionally, the fine-grained condition achieves dominant control even conflicts to the coarse-grained.
Let's have a cafe talk. It is not literally cafe, but is actually a combination of the concepts of coarse and fine into one word.
In summary, we propose Cafe Talk, the first 3D talking face generation model enabling coarse and fine-grained conditional control in an effective, precise, and flexible manner. We design a two-stage training pipeline that explicitly disentangles speech audio and fine-grained conditions. Additionally, we devise a fine-grained control adapter that gradually introduces fine-grained conditions without jeopardizing lip synchronization. We introduce a swap label training mechanism and mask-based CFG technique in the inference process to disentangle coarse and fine-grained conditions, which achieves dominant and precise localized facial control. We devise a text-based AU detector to efficiently extract AU fine-grained conditions from natural language descriptions based on user intent, which enables our model to support multimodal control. Thank you for your watching.